let's look at MySQL implementation within Red Hat Enterprise Linux. MySQL is a dynamic RDBMS or DBMS database management system that is widely available and ships with most Linux distros. So it features DBMS engine and is compatible with many front ends with various front ends, including scripting languages such as Perl, PHP, as well as front end interfaces like ODBC. It also includes GUI management, etc., etc. So it's a full-fledged DBMS which is used on many mixed type systems throughout the world and is included with Red Hat Enterprise 5. Version 5 is the current major release, and we're going to go ahead and install it. So let's set up a task to install MySQL clients and server. The client packages or client software can be found in the client package, which is simply MySQL, followed by the version name, and the server engine, the DBMS itself, can be found in the server package. We'll use Yum to perform the installation, but before doing so, let's launch a browser and connect to our RPM repository, our Yum repository, to show you the list of packages included with this release. Once at the page, we'll search using Control F when this is completed. And there we see a Python interface, a free radius interface, DBD, modauth, which is an Apache module, and lo and behold, the MySQL RPM, which houses the client packages. The client packages include MySQL, which is an all-purpose client, as well as tools such as MySQL dump and MySQL import, among others. The other main program is MySQL-server, but there are ancillary programs such as an ODBC connector, a benchmark program, the development package in the event that you'd like to compile a program against MySQL, such as Snort and IDS, to provide a hook into MySQL. There's also a test package. But we're interested in installing the client package as well as the server package reflected by these two programs. So with that said, let's navigate to the shell and perform our Yum installation. We'll close screen, reset the buffer, then yum y install MySQL. This will search repository as usual, as we've done so many times to install MySQL. It installs dependencies, including Perl DBI, and momentarily, if we RPM query all grep MySQL, we'll see that it's installed. And if we enumerate the contents using query lists, let's go ahead and RPM query list MySQL. You'll see that it includes support for multiple languages, but more importantly, the client utilities that help you to interact with the back-end DBMS. So starting from the top, we say config file. That's located in the ldso.conf.d directory. There's a primary config file located in etc. This is my.cnf, and this file can be used by both the clients and server package or programs. And we've installed it using yum y install MySQL, and it includes some key items. This is the primary config file, and it contains directives for both the server as well as client programs. There are a list of client packages located beneath user bin. Any user on the system indicated by the location, user bin, but more importantly, the permissions associated with those items, can access these programs. And as mentioned, the key programs include MySQL. This is the primary client used to interact with the server. So this is primary client used to interact with the server, but there are other ancillary clients that allow you to perform specific functionality, such as dumping a database or all of the databases on a server for backup purposes. MySQL admin, which allows you to perform administrative tasks. So this is the primary admin utility, which allows you to perform tasks such as changing administrator or any user's password, start and stop the server, amongst other things. MySQL import, which allows you to import data from text or other sources into a table structure, and other utilities. Again, there are also drivers included to provide MySQL client support for various programs. Programs that rely upon these drivers will complain if they cannot find them, the live MySQL client. And the MySQL package provides them so that you can avoid those issues. There are man pages for each of the client programs, which instructs you on how to use the client and how the client uses the config files, global and user base, support for multiple languages, and so on. Now again, because it's in user bin, if you type my and tab it out, you'll see the multiple clients: MySQL, admin, dump, import, show, access, so on and so forth. They're all available to all users on the system, and you can use the client to connect to remote MySQL servers, since it is a client-server program, but since we have not installed the server, we'll be unable to connect to the local instance. For example, if we were to try to connect using MySQL, user root, for example, this would default to the local host and return that it's unable to connect to the socket, and that is the Unix domain socket, because it isn't running, it isn't installed. So that leads us to the next step, which is to install the server using yum. MySQL server will install the server package, which will then lead us to some tasks that you should perform, we will perform, and you should perform to secure your server. Let's give this a run, and there we see it's installing a DVD Perl module, which is required, and the server is now installed. Let's RPM queryless MySQL server to see what's contained or what's included, and we'll see from the top that there's an initd entry, which should come as no surprise. It allows you to start, stop, restart, reload, and manage the MySQL instance. Other important items, we'll scroll down. These are items that are used primarily by the MySQL engine and not directly by users, but nonetheless can be. There's a hot copy utility, there are hot copy databases that are running to target servers. And if we scroll down, we'll see that there's documentation for MySQL. And beneath varlib MySQL, this is the primary directory where MySQL will maintain its database entries, which you'll see momentarily when we bring the server up. Beneath user lib exec is the daemon itself. This is the primary program. So this is the DBMS engine. And when you start the service using service MySQL start, it will start this MySQLD entry. Again, init.d contains the entry that's of concern, MySQLD. So that said, we've installed it. Let's move forward with starting the server and setting up the default privileges. So service MySQLD start will attempt to start the server, and upon initialization, meaning the first time you start your MySQL server, it does a few things. It tells you that it's initializing the MySQL database. The server, like with Microsoft's SQL implementation, maintains a database named MySQL to contain permissions and references to different databases. So there's a system database named MySQL, maintained by MySQL, which is set up upon initialization, or the first instantiation of MySQL. It warns us that we should be sure to reset the password for root. That's a task that we need to do. And after that, there's some additional information regarding where to get items from MySQL's shop online, and the server is now up and running. So psef grep MySQL will reveal that it is indeed running, and it uses a default data directory of varlib MySQL. So again, if we lsltr varlib MySQL, you'll see that there are now entries. Each directory represents a database. So there's a test database, which is suggested that you remove, but it's used for testing purposes, and the main MySQL database. There are log files, there's a socket file, and a data file for the InnoDB format. However, if we enumerate the contents of MySQL, you'll see that there are multiple tables. These files represent tables in the standard storage engine format supported by MySQL, which we'll show you momentarily. So each of these items represents a distinct table within the user table within the MySQL database, or within the MySQL database. These are distinct tables, including a user table, database table, and other types of tables to manage the running instance. So it's up and running, but there's some defaults that need to be set. When MySQL is started, and let's just note that task 2 is to start MySQL server and modify perms for root. So to start, we use service start, and we should also ensure that the server starts when the system reboots. So check config, the name of the initd entry on will ensure that the service is up and running in run levels 3 and 5. And here we switched the L and Q characters. Let's update our notes so that Q comes before L. Now the service will restart or start whenever the system is booted. But as far as perms are considered or are concerned, when you connect to a default MySQL instance after having started it, the root user within MySQL has no password. So if you indicate MySQL you root, this will connect you to the instance, as you see here. It launches us into the MySQL terminal monitor, which is an interactive interface to work with the DBMS engine. When you connect, it tells you that you are in monitor mode, and it also tells you your connection ID, the version of the server, how to get help, how to clear a buffer, and you should end your commands with what you see here, and or \G is the escape sequence. And typically you end your commands with semicolon, which is what's reflected, although it looks like a colon. So we're in this terminal monitor. This is a client-server connection that's open, but we should set the permissions first and then use the terminal monitor. And to do so, we can take advantage of either set password or the MySQL admin utility. So let's give you the syntax. That's going to be MySQL admin for the user root. We'll set the password, let's say to ABC123, just so that it's no longer the default blank password, which will force users to authenticate to connect to the daemon. So to quit, we can type exit or quit, and we'll propel to the shell or reverted to the shell. And now we'll execute MySQL admin to set the password. And that has worked for us. Now, any of these utilities can be executed with the help option. So MySQL help returns the myriad options that are supported. Additionally, for each MySQL command, as we earlier mentioned or alluded to, the printout of the order in which configuration files are read is available. So this tells us that when you execute MySQL admin, it first parses directives in the global etc my.cnf file. It will then search the user's home directory, the currently logged in user's home directory, for a hidden my.cnf file. And then, last but not least, it will search etc my.cnf. You scroll up towards the top and you'll see the general options that you may use with MySQL admin. And there are many options. Iterations, whether or not you'd like to compress the connectivity between the client and the server, indicate a password for connectivity, change the port, set variables, connect using SSL, you name it. There are many, many options supported. But the admin utility goes beyond just those simple options of influencing connectivity. You can create databases, for example, by indicating MySQL admin, your credentials, followed by create database, or create space database name. You can flush. In other words, many of the things that you can do from within Terminal Monitor or from within the GUI environment to manage your DBMS, you can do using MySQL admin. Flush privileges, kill a process ID. Maybe you have a process ID that's using up the resources of your server, overwhelming it, change the password of a user, ping the server to see if it's alive. So for example, MySQL admin ping attempts to ping the localhost, but unless you indicate credentials, it returns an error. So you indicate root followed by P to prompt for password, and then after you've indicated the appropriate password, MySQL admin performs the equivalent of a ping to determine if the server is up and running, and whether or not you'd like to shut the server. So for example, let's say that is desirable, indicate shutdown, and this will actually shut providing we authenticate. You can also authenticate using any MySQL utility by indicating the password immediately next to the P option or juxtaposed to the P option. So we know the password is ABC123. This will shut the server for us without prompting us for a password, and momentarily the server will be down. When we psef grep MySQL, we'll see the instance no longer exists, and if we follow this up with status instead of shut or shutdown, it'll tell us that the server is currently not running because it's unable to talk to the Unix domain socket, which is accessible via varlive MySQL mysql.sock. Let's go ahead and service MySQL dstart to get it back up and running. And again, when the server starts, it maintains files beneath varlive MySQL, including its default databases, a socket file, and InnoDB log files. So again, MySQL admin provides you with various options that you may use to get a sense of what's going on. Let's take a look at the current process list on the local instance. We'll change this to process list, and it returns a tabular format of the current processes. And in this case, we saw ID2 for a connection that MySQL admin made to ascertain the process list. So basically, the admin utility logged in or passed into the MySQL database show process list, which showed up as a connection. If, for example, from a separate shell we connected, let's do so using the user root and password ABC123. So this has assigned to us connection ID 3, and then from the other shell we rerun process list. You'll now see both shells, or both sessions that is, both MySQL shells or Terminal Monitor instances. One executed show process list, the other one is currently idle because there were no processes being executed or queries being run. So it reveals the current connections, and the admin utility is a front end to different things that you may do on the server. So primary admin utility to return useful info and perform admin tasks from the shell. Great, now the server is up and running. Let's do one other thing. Install, just to illustrate connectivity from across the wire, the MySQL client on a remote system, and then test connectivity to our instance. So again, on the remote Red Hat Enterprise or the local Linux CBT Serve 1, we'll use yum-y install, since the repository is set up, MySQL. And then we'll attempt to connect. So let's navigate to a local shell that's available. Here's one. And this will install the client momentarily, at which point we'll then use the client to connect. So to connect, step B is to simply execute MySQL u root prompt for password, optionally indicate the password on the command line, but it's generally not a good idea as it will remain in the history of the user's shell. So we'll just be prompted, followed by the server name, which we can indicate. And let's just take a look to see where we are. This has been installed. So again, if we execute MySQL with the help option, you'll see the myriad options that may be run. These values that you see here are set based on global and or local configuration files. So there are defaults that are set for all of these items, such as which database should be a default, whether or not compression should be enabled, whether or not a local in file, an input file from a text file is supported for importing data, so on and so forth. But above that, you'll see the different options that pertain to connectivity to a remote system and or a local system, including whether or not SSL should be used, compression. These settings that you see above the defaults, when indicated on a command line, overrides anything derived from a global configuration file. So that's something we should note, just so that you have that in mind. So you execute MySQL optionally with options. That's what the brackets mean, that the options are optional. And these options override anything derived from a global or local configuration file. So note, MySQL command line options always override global, which means etc my.cnf, and or local, which means user's home directory, hidden my.cnf, configuration, directives. However, the MySQL client that's in use will always display a list of directives that have been derived from the global and or home or user-based configuration file. So it'll always at least set up a set of directives and options defaults that it'll use to connect a remote system, and it's up to you to then override those options when connecting to a remote instance. I'm just scrolling through the options here so that you get a sense for some of the things that you can do with the client when connecting to a remote instance. So again, these are the defaults that are set. So from the remote system, we want to connect, or from this local system, we want to connect to the MySQL instance running on a remote system. On a remote system, a good thing to do is confirm socket-wise, TCP-wise, using netstat, that MySQL is reachable. So netstat NTL, grep, and the port is 3306 on TCP. It is reachable because it's bound to all IP version 4 addresses. Whereas in a more secure setting, 3306 may be bound to the loopback adapter. So with that said, we should be able to connect from any remote host, providing we have the appropriate credentials. So let's go ahead and give this a try, and you'll see momentarily that it will fail because by default, you are unable to log in from a remote system as the predefined users. Let's try this to show you what we mean. MySQL, the user's root, will be prompted for a password, and the host will be 192.168.75.199, or the FQDN or short name. It prompts us, and we'll enter ABC123, but you'll see that the host .10 is not allowed to connect to this MySQL server. So it knows the server is there. However, it doesn't allow us to connect. Now let's show you why that's the case. From either of these shells, since we're here in a terminal monitor, let's show databases, which is a standard SQL command. It includes a schema, MySQL, and test. Let's then use MySQL. And by the way, use is one of the few commands that doesn't require semicolon. We'll then show tables, and this database contains an important table, the user table. The user table stores the users who may connect to, so it's an auth table, who may connect to the server. And users in MySQL consists of a username part followed by a hostname part. So with that said, let's select star from user, and if we scroll up, you'll just see that for each user instance, root for example, there is a field which stores the host that user root or the username may connect from. So root may connect if connecting from localhost, and root may also connect if connecting from linuxcbt serve4.linuxcbt.internal, but root may not connect from other hosts. These other items you see here are for anonymous connectivity. By default, MySQL permits anonymous connections. Limited access, of course, but nonetheless, it's still a security concern. Let's go ahead and just note MySQL users consist of the following. A, username, i.e. root. B, host, i.e. localhost. And together, both form the full username. So, a sample username is root at localhost. And the server parses both parts separated by the @ symbol to determine whether or not the user is permitted to connect to the server. So in order for the user from the .10 host, that's this local system, to be able to connect to this .199 host, we need to create a user named root, if that's who we'd like to connect as, at the IP address or FQDN, or create a root user who's permitted access from any host. So that's how you need to look at permissions within a MySQL context. It's based on both the username and the hostname part, and the server makes that determination, because when you connect from a client such as 192.168.75.10, this IP address, and optionally the FQDN, which is tied to this IP address, is supplied to the MySQL server. So the server knows who you are because the client supplies that information to the server, so that the server can make the determination as to whether or not you should be able to connect. Now let's move forward. We have a fourth task, and that is to secure the environment, secure the anonymous environment. So we'll secure anonymous account. And really the only way to do so is, or two ways to do so, is to either set a password for anonymous, if you'd like anonymous access to remain, or delete the anonymous account altogether. We suggest you delete the anonymous accounts using delete from standard SQL statement, mysql.user. This is standard SQL statement to mean db.tablename. We need a where clause to set our criteria, and the user is going to be equal to nothing. Again, let's just confirm why the user is equal to nothing. When we look at the shell, we see that there's a user nothing for the field, followed by localhost. And there's also a user nothing, followed by the fully qualified domain name. And then we've got two root users, followed by the two versions of the host name. So that's why we delete where user equals blank, because there are two instances with the default installation of user equals blank. So this is to be deleted, and we will execute this command from the shell by pasting it in, and momentarily the client returns the number of rows affected. Whenever you execute a query, whether it's a status-related query such as show tables, show databases, show users, or a SQL query, a DDL query, such as a delete, update, etc., or a manipulation DML query versus a DDL, or any type of SQL query, MySQL, the client, returns the number of rows affected, and we indeed expected 2 rows to be affected as a result. To confirm that the rows have been deleted, let's select star from user once more, and we should only see instances for the root user to be able to connect from the local system as localhost, or using its FQDN of Linux CBT serve4.linuxcbt.internal. Now, another thing you should do after you effect permissions or authentication changes is to flush the privileges. Flushing the privileges ensures that these permissions take effect immediately. Otherwise, the permissions that are in place will continue to persist for currently logged in sessions. So after you make permissions changes, flush the privileges to be sure that subsequent connections and existing connections can no longer proceed using the privileges that you've updated, whether it's removing anonymous, so on and so forth. Now again, we've mentioned that once within the terminal monitor window, you can execute certain commands to get information, such as show databases, which reveals the various databases, show engines, these are the types of database engines supported by this release of MySQL, with the default being indicated as MyISAM, which represents the table structure we see beneath varlib MySQL and the name of the table, such as MySQL. So this is the default storage engine, but MySQL supports many other types, including memory, which is like a tempfs. In other words, it stores the tables in memory, and this is great for running systems that need very fast or lightning fast performance of database information, but of course the information doesn't persist when the system loses power or resets. There's InnoDB, BerkeleyDB, a black hole, which is like dev-null, just for testing. Example, archive, CSV for those making use of comma-separated values. CSV will produce comma-separated values for you. And other types of storage engines. So show engines returns that for you. And you can also look at the current process list to see what's currently being processed, or what sessions are active to determine if there are any runaway processes or too many connections to your server, and so on. Now let's just briefly take a look at the shell. We did mention that there's a global configuration file in etc. That's the my.cnf file. This file contains INI, Windows INI styled headers and sections. So in the case of MySQL-D, the daemon reads the directives following this block, or following the header MySQL-D. It derives data directory, socket, where to store its information, and whether or not old passwords are supported for compatibility with 3x clients. There's a MySQL.server section, which is also processed by the server. It is to run as MySQL, the user, and the base directory is varlib. And MySQL-D safe, which derives with the log information and the PID file. So this file is read by default by the server. But don't need to memorize this. If you execute MySQL or the name of the client help, you will see the section that's read by the client. If you scroll up far enough, it tells you the names of the sections processed. The following groups, and they're called groups, are read. When you use the standard MySQL client, it will look for a group named MySQL as well as a group named client. So blocks that include these two names, and when it finds either or, it will process directives from it. And ditto for other programs, including the MySQL daemon itself. MySQL-D, the safe option, help, and you will see in the dump what options it uses, and MySQL-D has the same thing. So they tell you what options they read, and it says all other options are passed to the MySQL-D program, so you'd have to actually run MySQL-D to get a sense for the options that are supported. And of course it's not in our path because it's in user libexec. So that's user libexec, MySQL-D, help, to get a sense for the settings that are supported. And it tells you it supports many, many options, so we should use verbose help. And let's go ahead and indicate that, and you'll see momentarily, and there's so many options, including the default. But if you scroll up above the default section, you'll see the sections that are read by the daemon when it starts. Let's go up and try to find it in this dump, and the dump seems to be even overrunning our buffer, so it may not even fit within the window space. Let's just be sure. And the options, as it mentioned, are numerous, too numerous to dump, so we're unable to see it in this particular case. But again, the options that are supported by each and every daemon can be returned using man and the name of the daemon, or man and the client, so daemons and clients. And those are the options that you may enable or disable. And you can also set those options on a per user basis, which we'll show you momentarily. So let's create a fifth task, and that is to create a sample database. So create database address book. We always like to create a simple database to give a sense for how easy it is to use the SQL commands and get up and running. So we need some SQL commands. We first need to create the database. So let's go ahead and indicate that. And in fact, you can script or lay out all of this information in a script and have MySQL read it using standard in. So we will just insert all of the statements here and dump it to a separate file, and then instruct MySQL, the client, to process that file. So the first step is to create database, and we'll name it address book. That's the first command, and perhaps we'll label address book with capital A and B to delineate between the two words. Then we'll create table contacts. In it, we'll have a contacts table, which will store certain fields, which include, using backticks or single quotes, first name, setting it to cart20. The data type supported by MySQL can be returned or researched using the documentation provided with MySQL. But many of the data types supported by standard SQL engines are supported by MySQL, so there really isn't much new here. So we'll set last name to cart20, and we'll keep on going. New line, business phone, cart20 as well. And again, you can be more precise in your setup. And you can also find many scripts online, many MySQL scripts that you can make slight modifications to and also learn from. So email is cart30, and we want to set a primary key on email. So primary key on the email column. This is an important column. We don't want duplicate information for this particular column. So with that said, this will create the database and create the table. We can do it manually from MySQL terminal monitor. Let's find that instance. We will also drop it and recreate it using a script or an input file. So there's the database. Now when we execute show databases, you'll see it. And by the way, MySQL, the client, the terminal monitor client, maintains a command history like the bash shell. Just use the arrow key to go through that history to reference a recently executed command. So now we've got an address book database. But before we create the table contacts, we should use address book. You want to change the context to the appropriate database before creating tables. This applies across the board. So now we're within the context of the address book database, and if we show tables, 0 rows will be returned. Now let's create the table contacts with our important fields, and of course this can be all altered once it's up and running using the appropriate alter command. And now we'll attempt to create a table, and it tells us that there's an error in the input near the email field. Let's take a look to see what's wrong with our output. Chances are we're missing a comma to denote the primary key, and there it is. So let's just include a comma in our output. We didn't include one after the email field. And now we actually have a table. So let's show tables, which should be in our history somewhere, and there's the table. You can describe the table using describe, which is another SQL command. So describe contacts, and there's a description of the contacts table, which includes the names of the fields and their field types and whether or not nulls are permitted, primary key, which can be on more than one column, if there are any default values, and any extra information pertaining to those columns. But of course, if we select star from contacts, 0 rows will be returned. There's no data in, or there are no data in the table. So at this stage, the next logical thing to do is to insert data. But we did want to show you how to effect all of these changes from a script. So what we'll do is create a new file, and since this is occurring on the remote system, we'll paste it into the shell. And in the home directory on the remote system, we'll nano, then paste, and then we'll save the changes. Let's make sure this is all on one line so we don't clobber anything. Save the changes. We'll write it as create address book db.mysql. So now we've got this file, create address book db.mysql. The MySQL client, if you run it with help, will accept a file from the command line using standard input, which means we use the less than symbol. So here we finally have an opportunity to use standard input redirection. MySQL, various options for authentication, the database to affect it to, or input redirection, which will include the appropriate SQL commands to create the database, select the database, so on and so forth. But the database already exists, so what we should do is drop it using drop database, which is again a standard MySQL or standard SQL command that MySQL implements. Drop database address book. And by the way, tab completion is supported for the name of objects in MySQL. Now when we execute show databases, which is in our history somewhere, we'll see that it no longer exists. And with that said, from a separate shell, let's attempt to import the file using MySQL. And user root, password abc123, which again is not a good idea because it remains in your history. Import of the create file will echo the exit status. It doesn't appear as much as occurred, but if you get an exit status of 0, it means your script ran as expected. So with that said, in the separate shell, or the next shell, show databases reveals address book, use address book, show tables will reveal the contacts table, describe contacts will reveal the structure of the table, but of course it contains no data. So the last step for us is to insert some data into this particular table. And there are various ways, of course, to insert data, but we'll use the simple SQL insert command. So 6, insert data into contacts table using insert. So a simple insert command would be as follows. Insert, and we like to capitalize, so let's go ahead, although it's case insensitive. So insert into contacts, the name of the table. Then we format the fields. We specify the fields. This is only one form of the insert command. So with that said, we know that first name comes first, so first name, then last name, but you can indicate which field you'd like to affect, and providing you don't break any of the database rules, such as rules pertaining to whether or not nulls are permitted, then you should have no trouble inserting nulls or inserting values into the table, into the column. So first name, last name, business phone, number 1, numero uno, and the email address. These are important fields. We know that email is a primary key, so it has to exist, and it must be unique. Now we need to specify the values. So the values will include the following, which will be separated using commas and delimited using, or indicated distinctly using single quotes. So we need a first name. Let's go ahead and describe a first name, followed by a last name, and a phone number, that is. We'll use our phone number. Followed by an email address. A unique email address will do the trick. This will insert the values into the contacts table. And we should semicolon this. Of course, most commands, most if not all commands, should terminate with a semicolon. So back to our terminal monitor, we'll execute the insert, and one row has been affected. So now when we select star from the contacts table, we'll see that there's one record in the table. Now regarding the primary key note, if we try to insert this record again, notice duplicate entry. So it doesn't allow us to insert the data. Of course, SQL protects us from that information, from that happening. We could change the email address slightly. Let's setting it to K1, and note it allows us to do so. How do we delete items? Well, very simple. And we'll list as our 7th task, delete record from contacts table. And of course, that's a simple delete statement with a criteria, not from the cron table, but from the contacts, where email is equal to the following. Use single quotes to avoid interpolation wherever possible. So let's try this, and barring no errors, when we rerun select, you'll see that the second record has been removed, and now one record remains. So deleting is straightforward, so long as you indicate a criterion. If the criterion matches more than one record, then of course n number of records will be removed. How about updating a record? So as our 8th task, and again these are simple SQL tasks, but as our 8th task, we will aspire to update a record. in the contacts table. And a very simple update using a criteria. So update the contacts table, setting a column that we'd like to update. So supposing we wanted to change the email column, as long as it's unique, it doesn't impact or it doesn't try to duplicate an existing email column, we should have no trouble, or email record that is, we should have no trouble. So we'll set email equal to, let's now go with 2 at the following address. The criteria is important, and we can do it based on the existing email value or based on any other column, so long as it's unique. So let's go ahead and say where first name is equal to, and this will perform an update query, a very simple update query albeit. Now with that said, let's go ahead and notice it tells us how many rows match and how many change. Let's select star, and there you see the email address has been updated. So to update is quite straightforward. You can also import data using MySQL import from a text file, so long as it's structured similarly, with the first name, last name, business phone 1, and email columns listed in that order. MySQL import will import the data directly into the table and provides an easy way for you to go from, let's say, a spreadsheet or database form from another type directly into this particular MySQL table. So thus far we've done a little bit with MySQL. We haven't by any means delved deep into it. We've showed you how to set it up, ensure that when it reboots it starts, how to tighten the privileges a little bit so anonymous doesn't exist, how to set root's password, how to create an address book table, insert data into it, manipulate that data. And for more in-depth information about MySQL, of course, by all means take a look at Linux CDT MySQL Edition or Featuring MySQL, where we go into, for a good 30 hours, everything you need to know about MySQL, consequently making you more proficient in the tool. So we'll move forward with other studies momentarily.